Okay, so we have one more problem here to find the solution to solve this differential equation. So let's try to do that. So we have d theta, let me just rewrite this, by dt is equal to t secant theta by theta e t squared, e to the t squared. So what do I want to do first? Well, first I will multiply by dt, both sides, okay? And I will also multiply by theta e, so multiplying theta e to the t squared. So also do that. What I do on one side, I need to do to the other side. Theta e to the t squared. Sorry, it looks weird. E to the t squared. So let me look at the cancellation. So dt, this, and then this just becomes theta e to the t squared d theta is equal to t secant theta dt. So we need to get the thetas on one side and the t's on the other side. So divide by secant theta both sides and divide by e to the t squared, or we can just multiply. So let's just do that. So this is just going to be 1 over e to the t squared, just multiplying that on both sides, 1 over e to the t squared. And then also multiply by 1 by secant theta. 1 by secant theta. So I don't have space here. I'll just write it up here. 1 over secant theta. So what will happen here is this will cancel with this. Yeah, there you go. And let's see, this will cancel with this. So you'll end up with with theta by secant theta d theta is equal to t by e to the t squared dt. Okay, now we just need to integrate both sides. So this is just integration. Okay, so this is just some plain old integration. So what is the integration of theta by secant theta? So let's think about this one a little bit. So this is like integration of x by secant x, right? This is basically dx. This is something like this. So one thing that you need to know is that secant, what is secant equal to? So you need to know that secant is equal to 1 by cosine. Cotangent is equal to 1 by tangent. Cosecant is equal to 1 by sine. So if we look at like x, so that would be how it is, right? So secant x is 1 by cosine x. So this is just integration x by 1 by cosine x dx, which this, whoops, what is that? Okay, this is going to be equal to, can't erase this. Alright, this is just going to be equal to the integration of, so x times cosine x cosine x dx. Now this is quite simple. You just need to use integration by parts for this one, right? So that's it. This is just going to be integration of theta cosine theta d theta, and then this is equal to integration of t by et squared dt. We'll worry about this one next, but we'll do this one first, right? So what is the integration of this side? So let me just write this separately. Integration of theta cosine theta d theta, or yeah, d theta. Let's see this, d theta. This is equal to integration by parts, IBP. Integration of u dv is equal to uv minus integral of v du. U is equal to, so light, right? Light, this is the acronym, light. So let's first, we'll think about the algebra. So u is equal to theta. So integral of, so if we look at theta, so this is theta, u is equal to theta. So du is equal to d theta. And then dv is equal to cosine theta d theta. V is equal to the integral of cosine theta. The derivative of cosine is negative sine, but the integral of cosine is actually positive sine theta plus c. We don't need the plus c. So theta times sine theta minus the integral of sine theta times d theta. Now this is much easier because this is just equal to theta sine theta minus, so integral of sine theta is actually negative cosine theta. So this is just going to be minus negative cosine theta. And then we have plus c, of course, plus c. We can add that there, whatever. So this is just theta sine theta plus cosine theta plus c. But so here we don't need to write the plus c because we can write the plus c on the other side. So this is just going to be equal to theta sine theta plus cosine theta. This is on this side. This is going to be equal to the integration of t by e to the t squared dt. So let's see if we can use some simple like substitutions or something like that, right? So let's see if we can do that. So if we set u equal to t squared, du is equal to 2t dt. If we can input a 2 and we can output put outside a 1/2, this is just going to be 1/2 integration 2t dt is du, and then this is 1 by e to the u power. Now this is easy because this is just equal to 1/2 integration e to the negative u du, which is equal to 1/2. So e to the negative u, we did this before, is negative e to the negative u plus c. So it's negative 1/2 e to the negative t squared plus c, or also equal to negative 1. So it's negative 1 by 2 e to the t squared plus c. Also that. So now we can write this. So this is theta sine theta plus cosine theta is equal to negative 1 over t2 e to the t squared plus c1. Okay. All right. So now what do we have to do? Well, we can try to isolate something. We can try to isolate a variable. We don't necessarily have to do that. It's not something we have to do. We can always say this is our differential equation, a solution to our differential equation. So let me actually just do that. Let me just say this is our solution. It's not required that you always have to write like one variable equals the other, one variable on one side and equals to an expression with the other variables. You don't have to do that. So this is something that you can leave it as well. All right. So that was this video. It's a solution. It's a little bit of a longer solution, but it's good practice for integration by parts and some basic trigonometric rules as well. Hope you found this video helpful.